Hi, this is the first in a series of example problems for calculating ASME code problems. So in this one, we're going to calculate the thickness required for a piece of tubing. Okay, so I have my example problem here, and as well I have my ASME code document ready to go, and we're going to work through these guys together. So example number one. Calculate the minimum required wall thickness of a superheater tube. The tube is 76 millimeters OD, outside diameter, and is connected to a header by strength welding. The maximum allowable working pressure is 4,150 kPa gauge, and the average tube temperature is 400 degrees Celsius. The tube is made of seamless carbon steel tube with a specification SA192. Okay, so first thing that we want to do is just scan the question and identify a couple of keywords that we're going to make use of. Okay, so first one, we are trying to calculate the thickness. The other thing that we're trying to do is identify what type of component it is, and it is a tube. So we are looking for the thickness of a tube. All right, so first thing we're going to do is go to our ASME code, and we're going to scan through our code in order to find an equation for tubing and then the thickness variation. And so if we look here, I have my equation. It's in my tubing section, and I have two variations of it. However, I want to calculate my thickness, so I'm going to use this variation of the equation. And typically what I would do then is write it down. So I'll write it over here. So my thickness is going to be equal to PD upon 2SW plus P plus 0.005D plus E. Okay. And then what I typically want to do is just, now that I have my equation, double check. All right, so sometimes in these equations you have some funny stuff with the number of decimal places, and it's easy to make errors that you've got the wrong number of decimal places. I see that a lot. So just double check you've got your equation correct. And then from there I want to make a list of all of the variables. So I see I have a P, I have a D, I have an S, I have a W, and I have a lowercase e. And I want to make sure that I'm able to find all of these things. Okay, so if I'm not 100% sure what they are, I can always go through my code and I can get to my symbols. So for instance, if I wasn't sure what really D was, I could always go and find that it's the outside diameter, or else I can find, for instance, my S, so it's the maximum allowable stress, okay, and we're going to have to go and find those values. So right now I'm just going to write down what I know, and what I know is my pressure is 4150 kPa, my diameter 76 millimeters, my S I don't know yet, my W I don't know yet, and my E I don't know yet. Before I move off, I just want to confirm my units. So I know all of my units have to be in either millimeters or MPa. So this guy I'm going to have to convert, and he would be 4.15 MPa. Okay. That pressure is in gauge, which is the correct type of pressure, so that's good. All right, so I have two things or three things that I need to find before I can solve this problem. Okay, so let's concentrate on S. S is the strength, and in order to find that, I'm going to need a couple of things. I'm going to need to know the tube average temperature, so 400 degrees, and I'm also going to need to know the material. SA192. And with that information, I'm going to go to my material properties in section 2, table D. Okay, so I've made my way through my document, and I'm down towards the end, so about the last half is what I've given you, and I have my material properties. And so what I want to do is I want to scan down my specifications and find my material. Happens that this is in the first page, so that's great. However, just remember that you have groups of 4 pages, so if you didn't find it in the first page, if we go down, we have another set of materials in the 5th page. So it keeps repeating that pattern. However, I was able to find my value on this first set, and it appears to be here. Okay, so SA192, it is a tube, which is a good thing, and it doesn't have any restrictions on the size or thickness. Okay, so I'm going to remember line number 12, and I'm going to then move on to page number 2 of my properties and make sure it's an applicable material. So on line number 12, if I continue across, I'm going to take a look at my section 1 materials. All right, so it shows that on line number 12, my material is good up to 538 degrees Celsius, and I have a temperature of 400, so it's a suitable material for section 1 calculations. All right, so I'm going to keep on going. So down to number 12, and I'm going to come across, and I know that my temperature for my tube is 400 degrees, and so the intersection of 400 and 12 is 73.3. Now this value is in megapascals, so 73.3 megapascals would be my stress. Okay, so I have a stress of 73.3, okay, and that was in megapascals, and even sometimes I reference that, so that was my section 2 D would be where I found that material. Your 3rd class level, you don't require to have written out solutions. If you continue on to your 2nd class, this type of question might come up, and you should reference where you found that information. Okay. My W is my weld strength reduction factor. Okay, so I have my weld strength reduction factor, and in order to find that, we scroll back up, and we have all of these tables. Okay, so first thing that we're going to note is that these tables only really start to come into play if we have temperatures that are up in the 450 to 500 degree range. So this material, even if it was a susceptible material, wouldn't even be at a high enough temperature to warrant any change. So in this case, W is going to be 1, and I guess that would be from table PG 26. And then the last thing that we would have would be E, and E is that expanded ends. Okay, and since this material was strength welded, we have a value of 0 for E, and that is 0 as it is strength welded. And that would be from PG 27.4.4 and note 4. So now that we have all of our data, we can throw that into the equation and solve for our minimum thickness. more space here. So my thickness is going to be equal to 4.15 times my diameter 76 upon 2 times 73.3 times 1 plus P, so 4.15 plus 0.005 times 76 plus E, which is 0. So sometimes it's better to do this in steps. We do have brackets and top and bottom and lots of steps, so just be careful. You don't want to get to this point and have done all the hard lookup work and then make a mistake with your calculation. So for instance, if I wrote it out in steps, 315.4 150.75 plus 0.005 times 76, 0.38. Thickness is equal to 2.472 millimeters. Okay. And what that provides you is the absolute minimum thickness that's needed to hold back that pressure. Now, that doesn't mean that a tube that is 2.472 millimeters thick is going to be suitable. You still may have to account for other damage that may happen to the tube or the support structure to hold it in place. But that is just telling you, as a bare minimum, any tube that's going to be used in that type of pressure application, in order to hold the pressure, has to be